Okay, so in question 10, you're asked to use node voltage analysis, okay, to determine V and I. Okay, so we have already okay, so the question already given, so a point here. So the whole idea is node voltage analysis is when you declare a node, you can take it that all current flow in, all current flow out. That is an easy approach. Even if you decide that from that nodes, some current go in, some current go out, is also fine. Okay. As we seen in the studio as well, you make some assumption and then you derive the equation. And after that, when you get the final answer, you will be able to know whether that assumption was correct or not. Okay. So in this case, okay, what we can do is, again, you may have tried something else. As long as your approach and your technique is correct, I think that is important. All right. So in this case, what we're going to do is we're going to assume that this is the node over here. Okay, and we're going to say that all the current is going to flow out of this node. Okay, so the expression, okay, that we will get is V. So if we take this branch over here, maybe this branch over here, you will get the expression of V minus 6 over 0.2, because that is the current that is flowing into this branch over here. Okay, same thing over here, you will get V minus 5 over 0.1, and in this branch, you will say it's V minus 4 over 0.05, and in this branch, you will say it is, this branch you will say is V minus 0 over 10. Okay, and once you come up with all this expression, okay, for the different branches from the node, okay, you can put them all together. So you can just say that V minus 6 over 0.2 plus V minus 5 over 0.1 plus V minus 4 over 0.05 plus V minus 0 over 10 is equals to 0. Okay, so you just do this and then the rest is all maps. Okay, so the important thing is this first step, to define a node and come up with expressions with that node. Okay, so the technique that so far we've been using in the studio and here as well is we either assume all the current flow in or all the current flow out. Okay, but if you want to try some other sort of combination where some flow in, some flow out, is also fine. Okay, you will still get the same answer. All right, and then from there you can derive or solve. Okay, and yeah, so usually you can solve by factorizing out the denominators first. I mean, in terms of the fractional part here. So 1 over 0.2 plus 0.1 plus 0.05 minus 0.05 equals to 0. Okay, and then the rest you solve. Okay, if in a calculator you know how to key in everything one shot and just get the answer, then that'll be good. All right, so you get V is 4.56 volt, so this is the voltage here, and then from there you get your current. Okay, so that is basically how you can solve this. All right, by as long as you making sure that you follow the same rules. Correct, you define a node and then you create the expressions for each branch that goes to that node, and then you either add up everything, okay, and you say equal to 0.